Welcome everybody to Dallas Programmable Robotics Group Robot Builders Night Virtual for December 2nd, 2025. Tonight we will go through our regular roundtable of presenters, and after that we can have an open mic, and if you have any questions or stump the club type questions or questions about anything in general, let her fly. As long as it's robot related is what we try to do. So to start off tonight, I just wanted to remind everybody, get your robots ready. There's only 172 days left until Roborama. So get building and see what we can end up with. Usually it's at the end of May or early in June, so roughly 180 days. With that said, we'll start off with Mike, who's working on a new project.
Yeah, so I built my huge robot for outside that failed miserably because of a bad parameter, and at the Robo Columbus, and I have my 6-can robot that has a lot of precision to it, and both of those run on ROS. I think I'll keep ROS, and I decided I wanted a tiny robot. So I decided the mini Sumo robot was what I would do. And instead of buying a kit, which might have been a little more cost effective, I decided to build it, but I'm building it out of modules and not a custom circuit board. And it's a pretty tight fit. So what I've been working on right now is, well, I put a schematic together, but the more interesting thing is the mechanics. And so I have let's see where it is. So I have a CAD file. So let's see, CAD, there it is. Yeah, so this is what I have right now in my CAD file. And so I have the forward and backwards obstacle, or not obstacle, but detection sensors to detect the other contestant, and I put the cones on here to show their effective range of them. And Mini Sumo is 100 or 10 centimeters by 10 centimeters, which is the box here. And I put on here is the floor, which is where it's basically at the ground level. And so you can see in here, I have all the components. And so if you look at this, I decided to build it. Come on. So I'm designing it to be 1 millimeter off of the floor, the platform. So it basically isn't scraping the floor, but it's really close to it, which is, I think, the right approach for the Mini Sumos. And all the stuff took up so much room, I was able to afford it a little teeny lip here to try to use it as my weapon to attack. And I've been working on my okay, let's just go through here and dissect it, I guess. Let's go back to the isomeric, and let me get rid of some of these. Like, this is the front. I put the front at a slope there. I was trying to figure out why people put it at a slope, and I think it's sort of camouflage. I mean, like the stealth fighters, everything's at a slope. And because I noticed that the sensors don't like things at 45-degree angles. I mean, they can't see it very well. So this is my 45-degree angle. I couldn't fit 45 degrees anywhere else on the robot. So I believe that's what it is. So I'm gonna take that one off, and I'm gonna take these off just to
Oh, I thought it was to get underneath your opponent and, take away his traction.
Yeah, well, that's what I have that little lip on the front for, is to get under it. And also, when you're talking about that, if I look at the side here, I realize if this was completely flat, if someone went under here and started lifting it up, I'd lose my wheel traction. And so in the back, I have it at like an angle here, so that I keep the wheel traction even though it gets lifted up a little bit. So instead of this being completely flat, I decided to put an angle on there, like a wheelie bar, and so when someone tries to pick it up on the front, then I can still have traction on my wheels, because otherwise the wheels would have been easily lifted off the ground and no traction anymore.
That's what they do with RVs, so you don't bottom out on, dips.
Yeah. Okay. So I'm going to get rid of this ground plane here just to keep things simpler. And so, where's my circuit board?
Can you make the front like instead of a point that runs into an angle, a vertical? Can you make it like smooth so it doesn't catch or stick just above the pointed part?
Come again?
That kind of defeats the purpose of sumo, though.
What's that?
Sumo, you need something that you can push against, and if you angle everything, you can't push.
Oh, but you'd probably be up underneath it at that point, right?
Yeah, you might get underneath it, but you wouldn't be able to necessarily push it at that point. They can just roll right over the top of you.
Oh, that's true. Yeah, I've seen some designs that have a really thin metal blade that comes out like 10 centimeters. I didn't have any room for anything like that to sort of try to pry underneath the front of it. So I figured when the wheels are running, the front's going to be pushed down with the angular momentum of the wheels, and so basically when you're going forward, you're going to be at the ground. You're going to be scraping the ground at the very front. Okay, so let's go through this thing here. Let's go back to standard isomeric. Okay, so basically, I have these sensors here that I've been testing out, trying to understand them. Those are just some really inexpensive sensors. Can everyone pin my screen?
Mm-hmm.
Yes.
Yep.
Yeah, this is the sensor here. Yeah. So.
Oh, it's infrared. Yeah. Emitter detector.
They're relatively inexpensive, so that's good. And I also have my line sensing sensor, which is this one here.
Oops, it's out of the field of view. There it is.
Yeah, and that one points to the ground, so it can see the line. And let's go back to my presentation. Where'd it go? Ah, and so these 4 modules here, 1, 2, 3, 4, are my my not so great sensors, which it has those LEDs on the front that are really inexpensive. And I was digging through my drawer and I found this sensor here. It's a STVL6180, and it's a relatively older version, but it gives me a depth. Like these sensors here just give me on or off. And like if I like this one here, this guy's cone is a little bigger, I noticed. It can go a couple 180 millimeters out. And and it has like a 30-degree range. I couldn't find the field of view in the data sheet, so I just tried to do a measurement of it just on the table here, and I figured it's about 30 degrees. And then these.
Is this one a single point?
Yeah, single point. Uh-huh. Yeah, they're relatively inexpensive compared to the other stuff, but and I had it, so I said, okay, I'm going to use it. See,
on my Sumo mic, I have the infrared pointing forward, and I also have infrared pointing out to the sides. I don't know how I have any pointing backwards. Have you thought about pointing to the sides to see if anyone's getting around you?
I thought about it, but I just didn't have any room.
That's fair.
So I noticed that a big strategy seems to be to circle around to the back.
Oh yeah.
And so I want to know when someone's back there. I haven't figured out what I have to do when someone's back there, but yeah.
Been around and charge. No.
Yeah, so you can see here that this sensor is an on-off. So if something's in this range here, I get a digital bit that says, "Hey, something's there." This one here gives me a value how far away it is.
How far away? Nice.
Actual distance.
Very cool.
Yeah. So basically, it's where I home in on stuff, try to find out what's going on. And I decided instead of having switches, I'm just going to use these sensors as my switches. Like put my finger in front of the thing like at 0 millimeters and use that as my start switch instead of a because it just says, oh, I got sensors. They're not doing anything, so I just use them as commands and to get it going. And once it starts up, then it goes into the mode of detecting stuff. Okay, so those are those, and this. So I've made myself some room right here for a circuit board. I might be able to go back a little further, but it has to squeeze into this tight fit. So I'm going to find out how big I can make it. So I'm going to lay off on the circuit board until I get the chassis pretty much built with some standoffs, and then I'll figure out how exactly big can I make it, and then how big does it have to be. I think this is big enough. If not, I can put a wing on it. I can put wings on it out here. So let's give it a start. Huh?
What are you going to use for a brain?
Oh, it's a RP 2040.
Yeah. That's
It has
what
a
I got
lot of.
mine.
It has lots of power and lots of I/O and.
I use the same in mine. RP 2040.
Okay, and so here's my.
So you guys aren't using the 2350
I haven't tried it.
RP?
Mm-mm.
No.
Yeah.
Nope.
I know the 2040s are
the
like less than
$23.50.
$2, and
Yeah.
the other ones are more like $8. But
Yeah, I didn't have them, and I didn't need the extra PIO, and it has enough horsepower. So,
Yep.
In fact, I'm not using much PIO on this. I'm mostly just using digital pins just to see if the sensors are on. So this is my prototyping board here. So you can see that the RP 2040 is here. Oh well, so it's. Oh, and then I got the motor driver, which is that other circuit board. And then these are sensors that aren't going to be on the circuit board; those will be wired to it. So that's my circuit board prototype right now. Let's go back to the CAD drawing, which is where I'm spending all my time right now. And so this right here is my battery. So the battery is a big piece of it, and so it takes up this entire space here. It's a 1200 milliamp hour 7.4 volt battery.
2S, yeah, or S2.
Yeah, and And I was looking, trying to figure out what would fit in this space. And then I finally found a battery that would fit in the space. So I said, okay, I'm gonna use that battery. It should fit in that space.
A good choice too, because you've got it biasing your weight in the front.
Yeah. So everything's low and has a lot of weight there.
You need a lead acid battery. You put more weight in.
And then you probably noticed that the wheels right there, if you look at the bottom,
Steamroller wheels.
these are the wheels. And then the motors are right here. And it was designed by purpose, I guess, for mini sumo, because everything fits like wheel edge to wheel edge is 10 centimeters. So I'm going to go back to if you pin me, I'll show you so here's the wheel. I decided I'm going to prototype a couple of 3Ds because this is very critical to get right. And so I have so that's what connects, what clamps the motors down, and it has to be really precise. And then this right here is my hub, which has to be really precise too. It's my wheel fender, because I don't want wires or batteries or anything going into my wheel. So so it's just a little protection on the sides to keep stuff out. And then sensors mount on the top of this right here. So everything is done. It has to be done. Huh?
Open loop, no encoders, or?
Oh no encoders for mini sumo. I mean, you could put them on there. I'm going to put a IMU on here, and that'll be my encoder. It'll give me a little bit of sanity about how much I'm moving or anything.
Yeah.
But mini sumo is basically a cockroach. It says, hit the line back up. If you see something, attack it.
Yeah, the reason why I was making those comments about the front piece, have you seen the blades you can put on the mini sumo robots that Polulu sells?
Yeah.
It's a pretty good sloped surface that's all the way to the ground and up. And I thought that was the goal, to get under something so you could easily, much easier, or it would be much easier to push it off the board.
Yeah, look, I would try to figure out how to put it in here, but everything, I mean, if you look on here, I got like these right here are the sensors.
Well, could you just slant it out like they do with the mini sumo blade, or whatever it's referred to as, the front piece of metal?
Yeah, because I wanted
from that point up.
I mean, there was just no room here. The sensors were relatively big because I'm just using these inexpensive off-the-shelf sensors here, and so these are. So if we look in here, I got my line sensors here, 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 and here. And if you look on the bottom, that's where they look out. So so the sensors can see the four corners of the mini sumo. And so basically it's like, oh, I couldn't get anything to fit.
Well, you don't have to take away space. I mean, you could, from the furthest tip of on the bottom, you could tilt that out a little bit, right? And then make the
like
top
This
portion.
is my furthest tip right here, and then the sensors are right there. So it's like a couple millimeters away.
Yeah, but you couldn't. I don't know. I thought the sumo blades worked pretty good.
I wanted to use them, but I decided I couldn't. Like,
because you'd go over the 10 centimeters.
Yeah. You have to be 10 centimeters.
Yep.
Yeah.
So I'm 10 centimeters by 10 centimeters, no more, no less.
So the rule is you have to be 10 centimeters before the match starts, but after the match starts, I've seen some where they have blades that drop down, they're pointing up, and then move back a bit, and it drops down.
Yeah.
So they can expand after the match starts.
Yeah.
Maybe that'll be my second robot. Or maybe, or if I enjoy this, maybe I'll do it more custom so that the sensors and everything don't take up so much space.
Yeah. This is great. I like this, Mike. Yeah, if you want to get together at the Makespace, I can bring down the arena, and I'll bring my Sumo in, and we can have some fun with them. When you get yours built up, of course.
Yeah. And so these are the clamps for the motors. So the motor and they do exactly what they said, and like they're almost touching. And if I go back here, I don't know if you can see it or not, but
Oh wow. Yeah. We almost need like a non-conductive wafer between them, just in case.
yeah. So I figured I'm gonna have to bend those little tabs out and put wires on them and just bring the wires out. Otherwise, they're perfectly fine. It's just
Snug.
The contacts on the motors almost touch to get to be 10 centimeters. But if you bend those tabs, you can probably pull it in a little bit more. But yeah, this is what I got. And
Very cool.
yeah, so
It's going to be all Python code.
oh no. See.
See?
Yeah. There's just nothing fancy to it, and you want all the you want the speed. You want instant reaction.
Yeah, that's true. Good point.
You don't
Where's
want
the fan or the glue to hold the wheels down?
to.
The traction.
Suction fan or glue on the wheels to hold it to the board.
Yeah. Well, these wheels here they're really
TPU.
they're silicon. I mean, they're just they have a lot of friction to them. So they were designed for mini sumos. I tried to use a TT motor and their native wheels. I got them back, and it was like, oh my god, there's no room for anything else, and it would be top heavy, and so I said, oh crap, I'll use that for another weird project someday, but it would not make a mini sumo. The TT motors and their native, I think they're 60 millimeter wheels. It's like, oh crap, that's bigger than I thought. Yeah, because these are like 20 millimeters or something. So, yeah, so that's my project right now. It's like trying to get all the dimensions right and testing stuff out, like chop out a little piece of it and then test it, make sure that it's the right dimensions for the sensors and stuff. And the motors were most critical here, so I was happy to get those working. But you'll see here that the front and back sensors, basically they're touching. Because when you put the front slope thing to it, which I think is just more of a just basically a stealthness of it, so you can't see it, so that someone else's sensors can't see it. I think you'll see that the sensors go right to there and they go right to the back, and the boards are touching. So it's like, it's just as small as I could make it. But I also noticed that if I turn that cone on, let me see, where's those cones? Yeah. Yeah. So if someone has a sensor that points out like this, you just have to use your imagination here. If you're pointing the other direction, this deflects the signal away, and since this is a cone, the bottom here deflects the signal down. And so if you had it sloped all the way from a stealth point of view, the bottom of the cone would reflect back on here and have a strong reflection. So it's like, that's a good reason to have, basically do this, because like I said, I have no room. Like this, I couldn't find any smaller batteries than this year.
Yeah.
And the wheels are the smallest I could get, and these are the standard sensors, and they're not that huge. So it's a toughie to build with standard off-the-shelf parts.
I think you'll find that there's a reason most successful sumo bots take their wedge all the way to the floor. And it has less to do with sensing and more to do with just deflecting your opposing robot's force upwards and not giving them a straight ledge to push against, like you have at the bottom there.
Right. So I don't think I'm going to be like #1 in the universe or anything with this, but it should be very respectable. And a lot of the components, like the wheels and the motors, I can reuse on another project that maybe I can do a better job of designing it more compactly by having custom sensor boards and stuff. So that's my I can just ramble, but that's my show and tell.
It's good. I like it.
Okay, so
if you're willing to spend a little bit of money and want to shrink your boards down, Paulu has the sensor board that they use in their robot, just as a standalone sensor board. So you can get that, and it's actually quite small.
Yeah, I was trying to make a real low budget one, then all of a sudden it's like I had to buy real wheels and real motors, because I figured that's the important thing, is to get some power and some traction, and it has to be small enough to fit in the package. And
Just to be robotics, there's no such thing as cheap.
That's
well,
fair.
I tried to do it, but I failed miserably. So that's my stuff. It'll keep me busy for the holiday. Yeah.
That's cool, Mike. Looks like a nice little project. Up next, we had Matthew. Matthew's got an update, a small update on his Micromos robot.
Sure, let me share my screen. Okay, it's not allowing me to share. Can't share your screen. Sorry, I'm operating from my new MacBook and it's driving me nuts.
I'm having the same problem trying to get my internet working at home. I'm switching
Having to
provider.
change some settings.
Yes. While you're playing, I'm gonna show my wheels with a ruler. You can see that they're exactly 10 centimeters. So,
I see from 3 to 7 centimeters.
Yeah, we had a portrait shot, so the size will cut off.
okay.
Well, we'll have to take your word for it.
There you go, right there. Yep.
Okay.
Yeah.
Looks legal.
Make sure you don't run the contest on a warm day where you have all this expansion.
Hang on.
I do have a question for people.
Put it back on the screen.
Yeah, these
Patrick.
wheels, these motors come with long shafts, and I gotta trim them off. There's 3 mm shafts, and I was going, I could use my hacksaw, but I don't want to damage the motor. Does
Mhm.
anybody have any thoughts about it?
Dremel?
Yeah, they have a really thin cutoff disc.
No, I don't. But I was thinking if I had a Dremel tool and a cutoff disc, that might be a little better than a hacksaw, because hacksaw
Oh,
has
yeah.
a lot of
Yeah.
vibration. And
Yeah.
A
So-
hacksaw is actually better.
oh, really?
Yeah, because
Sure.
the Dremel's going to put heat into it, right? It's going to be grinding operation. So you got to take off the wheel anyhow, because you don't want to melt your hub if you got a plastic wheel hub.
Right.
And also you're going to get a burr either way. So you probably want to take the wheel off and just scribe it nicely. And, you know, a hacksaw will take care of that in a heartbeat. You got to have a fine metal blade on it, but
Yeah.
yeah, we switched to power tools far too often, I think. It's amazing what a good hand tool will do for you.
Yeah.
And if
I didn't set the set screw on the wheels yet, because I figured I was going to take it off and cut. First of all, mark the shaft where I need to cut it, and then take the wheel off and slice it.
If you use a hacksaw, what I'd highly recommend is build yourself up a 3D printed jig that basically keeps the blade straight and marks where you want it to cut. And that way you basically will have everything aligned, and it'll help you get started on the hardened shaft.
Okay, thanks for the inputs.
Or you could stick the part that you want cut off in a vise, and that will hold everything. And
Well, that was what I was going to do.
Use the back of your fingernail as a rest.
I'm going to put a vise on
Back of your
beginning of
what?
Pardon?
I didn't hear what Karim said. Karim, what'd you say?
You use the back of your fingernail on your thumb as a rest for the hacksaw. It's the way I do
Yeah.
it. You wouldn't believe the kind of precision humans are capable of. It's
So I
bizarre.
figured I'd clamp the shaft on the vise and leave like maybe a couple millimeters coming out, and then do the hacksaw and hold the motor with my hand, and then do the hacksaw. Yeah.
Oh.
Carl is holding up a small saw, and I think he had a little miter box.
Oh,
Yeah. There's little options like if you look closely, you can find these tiny little miter boxes to help hold things, and then you can see the dimensions. It's a pretty make a nice narrow cut. I don't know how well it hold up against a hardened shaft, but
Those won't.
They won't. I wouldn't use that. This aluminum probably, and it's the hacksaw blade should go right through it.
I figured
You don't really need a really fancy setup. It's just a shaft, right?
Yeah.
You probably want to take a metal file to it afterwards just to clean it up and get the
I figured
burrs
I was
off
gonna
it.
I was going to wrap the motor up in tape to keep any of the metal filings from getting inside the motor.
That's a good
So you need
idea.
to seal the motor up before you do the.
Yep.
Just
Very good
watch
idea.
out for power tools. They can be dangerous.
there's another approach you could use. Just,
That's the fastest approach. Yeah. Leaves a really nice and
Ooh.
sharp shaft.
okay.
All right. Well,
That's probably the
Okay.
quickest. Yeah.
I guess Matthew's ready now. So yay.
Yeah,
Okay.
sorry about that. I had to quit and rejoin so Firefox would accept my new settings.
Great.
All right, yeah. So this one's not going to be very long, but last week I mentioned a couple updates. But since then, I have tested the motor driver component of my board. It works just fine, so I'm pretty happy with that. I also ordered the third rev of this PCB. So why make this new on this new board? Well, on this Rev 2 board that's pictured on the right, there was a lot of inconsistent soldering. This was the first time that I was working with components this small. So 2 of the MOSFETs and the gyroscopes were not functional because of solder bridges or not enough solder. There were a few problems with those. Second, I have these programming pads. I thought these were going to be an elegant solution to programming the device because I have this this clip that has pogo pins on it. So you clip this to the edge of the board and then it touches the pads. It works, but it's a bit cumbersome and annoying, especially if you're trying to do rapid iterations. Third, this one is not as bad as it sounds, but I miscalculated the motor width. So the fix here is to simply redesign the motor mount and print a new one. It's just, this is just an inconvenience. However, the fatal one, I mentioned this last week, this was the incorrect MOSFET design. I'm using these in-channel FETs to control the LED for the wall sensor. This allows me to drive the light at a much higher current than I could from just the microcontroller. The problem here is you have to consider high side versus low side switching when working with these, and I made a very stupid mistake. I put the MOSFET on the high side of the LED. So when you're working with FETs, the state of the MOSFET is controlled by the voltage between the gate and the source. So if I apply about 3.3 volts to the gate, the source is rapidly going to approach whatever the drain is. In this case, it's about 3.3 volts. So now I have gate and source at roughly the same voltage, which brings the differential between those 2 pins very close to 0. It's going to be underneath the threshold voltage to turn this FET on. So now I have a situation where the MOSFET is supposed to be on, but the gate and source are at the same voltage. And this can cause some unpredictable behavior. Now the fix is quite simple. You move the MOSFET to the low side, so now the source is always at ground, and there's never a case where the MOSFET should be on while gate and source are at the same voltage. So simple fix, but it's kind of embarrassing, and it requires a PCB redesign. So while I was doing the redesign, I figured I would change a couple of things anyway. One, I added more mounting holes. The array of holes on the left and the right are there to give me some flexibility when designing the new motor mounts. I have not finished designing those, but if I want to change things, I have a lot of holes to play with. Second, I added a physical programming header. That is the header on the right side of the board, just to the right of the microcontroller. It's the array of pads. I rearranged the circuits around a larger surface area. The previous board had all of the circuits within a 3-inch by 3-inch square, which is the size of my hot plate. However, this board is being optimized for completion. Since the competition is coming up in March, I don't have a lot of time to be playing around. So I'm going to have this board assembled by JLC PCB. So this is being manufactured and assembled by JLC. So now I can put the circuit. So now I can put the circuits pretty much anywhere on the board, and they can do the assembly. I approved those production files today, and I should be having it shipped in about 7 to 10 days. Unfortunately, due to lead time issues, I wasn't able to have JLC assemble the motor connectors on the back. So I'm going to have to solder those by hand when this board arrives. And I'll say the tariffs made this painful. It was almost $100 in customs fees alone. So on the total, including tariffs, is probably like $260, which was quite painful when the original quote was less than $150. So again, we're optimizing for completion here and just trying to get it done. So I am eagerly awaiting this board to be delivered here. That's just the small update that I had this week.
Does your motors have encoders? Do you use odometry or?
Yeah, so it's a combination. On the motors, if we scroll back here, I'm not sure which picture is better. So on the black section on the back of the motors, that contains the encoder.
Okay.
So both of them have encoders, but the gyroscope is used for a lot of the navigation. So, so during turns, it's going to be relying on the gyroscope. During straight runs, it's going to be counting the revolutions on the motors.
Mhm.
There's also a few things that we can do to sort of close the loop. Let's say you know that you're approaching a wall. You can use the readings from the front sensors to see how far from that wall you are when you're at start a particular distance. So if you have some wheel slippage, which does happen, you can use that as a fallback.
So can I ask how much of that, what, $160 or something, how much was the board and how much were the parts and the assembly?
That's a good question. I think boards were roughly $30 or $40, and the rest was parts and assembly. They really get you on the assembly, and especially on the parts, because they charge you a lot more for parts than the parts cost on DigiKey, for example. But it's fun.
They don't do any testing, right? So you just have to hope that they gave good parts and didn't damage them when assembling.
Yeah, I've heard some horror stories of PCB assemblers using counterfeit parts. So I'm hoping that doesn't happen.
Are you building like 3 or 4 boards a batch?
Yeah, so
Oh, you are?
yeah, they're manufacturing 5 PCBs. That's the minimum quantity. But for the assembly, the minimum is 2. So I'm actually going to get 2 boards.
Okay.
That's cool, man.
That's a neat.
So hopefully by next week we have a shipment that's almost here. I need to order a couple more motor connectors, or I can probably just desolder the one that I have on my board right now and use that. But yeah, we are taking baby steps. We're getting a little closer every day.
Well, thanks for the update. That's cool.
All right. Yeah, thanks for listening.
Okay, that was the end of our list of presenters tonight. So I don't know if anyone on the call has something to present.
I can show something. You want to see it?
Of course we do, right?
So everybody loves options. You know, you think, okay, there's several different ways to approach a problem, and if you have options, you want to explore them and see, which one's going to work out the best. So here are my options for the indoor contest, the 6 can. So this is okay, so this beast here is, I call it option number 1. Scott's the winner of the contest here. So this is it's actually an air horn tank for like a semi truck. And, the maximum PSI it says around the label here is 150, but I'm only going to put 100 in. And I have a solenoid.
Oh, is that all?
And
Just the
that
100.
tube that's not quite cut off and bent into the right position yet will point out like right in the center here. And so instead of going back and forth and depositing the cans, it'll go find a can, point it to the goal, and basically hit like a blast of air for a little bit less than a second. And it'll blow it easily 15 feet in that time. And if I position the nozzle right, it'll kind of knock the can over and actually.
The roll has to go through the goal or just end up on the other side?
Oh, through the goal, yeah.
Is it through the goal or through the wall?
It could be through the wall.
Or through the referee?
That's right. I'm obviously going to have to warn people, cans may go everywhere. So don't hang out at the end of the goal. A little disclaimer forms, in case my tank blows up.
Have to hire some EMS people to be there on standby?
That's right. Yeah. Anyway, so that's option number one. And I've tried, like pressurizing the tank and.
Well, that's clearly your winner.
Oh, you think?
Don't need to explore other options.
Oh no? Okay.
No.
And anyway, so the Scott's time to beat is like a minute and a half. And if I'm not making, trips back and forth to the goal, I'm just basically starting off at one end of the goal and taking the cans and blowing them into the goal. I don't have the back and forth trips, 6 trips. So I'm thinking with that, I should be able to get under a minute and a half. Now, whether all 6 cans get in there or not, I don't know.
What about bank shots?
Why not the leaf
You have to
blower
blow it
approach?
against the wall.
Say that again.
Leaf blower approach. Why not that?
That's a little bit more difficult. When David Anderson did it, it would just blow all the cans towards the goal. And
and yours is going to be so much more controlled.
theoretically, yeah. So
Okay.
yeah, because
What
we only do
kind of
one at a
shots,
time.
right?
What kind of
What?
nozzle are you going to have? What kind of directional control nozzle? Is it just a pipe or?
Yeah, just
Yeah,
a tube. That
Yeah, like two
this is a
things.
piece of like 1/4-inch ID tube that I haven't bent yet right into the right position.
Okay.
But just doing it in my garage, hitting it with a nozzle, it didn't seem, you could move the nozzle left or right a little bit, and it still seems like it would blow it in whatever
Oh.
direction you were pointing it.
Oh, good.
So, and like I said, it would easily, 1 second blast of air would, make it go like 15 feet. And most of the way it was airborne because the can would like where the nozzle is, it's just a little bit above center. So it would kind of launch it. And I'm hoping that I might have to reduce the time the closer to the goal that I get, because if it does arc, I don't want it hitting the top of the goal post and then falling still inside the course. It has to go through the goal post.
So it's not like football. We have to go through the little.
Go through the uprights. Yeah.
Yeah.
Yeah. Anyway, so that's option one.
But Ray, from an aiming point of view, do you have to have the can kind of well between the nozzle and the goal with the goal?
Oh yeah, I
have
still
the
have to get the
angles.
can and orientate the frame so it's pointing at the center of the goal. But I pretty much do that anyway.
But I mean, like, so I see 2 problems. The one is if the orientation, the placement is such that like you can't really get the robot behind the can aiming at the goal. So how about if you have the nozzle off center from the can, when you blow the air past, does the lower pressure of flying by like an airplane wing, does it pull the can anyhow and align it with the direction of the air?
Yeah, like I said, it's not real sensitive as to where, like if you're like straight on axis to the point that you want to go or not, it's so much air and the can is so light that it does just kind of suck it into the stream and boing,
Okay.
off it goes.
But you're not going to do any bank shots.
Oh no, God no. But I'm still going to have a claw, so I still have to go up and get the can, and then I'm going to position it so it's pointing towards the goal. Open the claws and hit it with the blast of air. So, I should be able to position the can where I want it.
Oh, okay.
Okay. The
So
claw
you're
adds
relying
an
on the
extra dimension.
You're relying on the Bernoulli effect to pull the can into the stream.
Yeah, and it's surprising how far it goes. I mean, just with a 1 second blast of air, like I said, it'll easily go 15 feet. So, I may have to do shorter bursts of air. And the other thing that may work out is that, the more air I use, the lower the pressure is going to get and the closer to the goal I'm going to be. So, but whether that's, the proportionalities of that are going to work or not, I may still have too much pressure and it, still may hit the, the top part of the goalpost or whatever you want to call it and fall inside the, the arena, I guess. So anyway, so option 2, Carl, should look familiar to you here.
Ray, do you have a pressure regulator on the output of the tank?
Nope. It's just, a solenoid and out through the pipe.
Can number 1 goes like gangbusters, and can number 6 may flutter
just
around.
knock over. Yeah. Hopefully not. It seems with 6 cans, I've filled up the tank and then, moved closer and closer to the goal, and it still seems like it has, enough pressure, but I may have to reduce the amount of time that it's open because, if I'm 2 feet away from the goal, I don't need, to blow it 15 feet. So
I do have another question about the arena blow can robot related. Is the arena fastened down to the floor in some manner?
no,
Or will it go flying with the wall?
I hope not. Well, the cans are so light, the can could probably hit the arena and nothing would happen. You'd probably dent the can.
Well,
I'm envisioning
hitting
lots of mangled cans.
Yeah. Thing
I'm
is, they'll have a
envisioning-
source of air so I can just, pop them back out. So
I'm envisioning the person who
don't-
built the arena being a little upset about dings in the wall.
oh yeah. Yeah, that's Scott's arena. So
I hope
We
your
can do
next
some
Combat
good job
robotics, so
painting
you
it.
can use a air-powered flipper to throw bots out of the arena.
oh yeah. Yeah. Well,
BattleBot.
this isn't a, it's just, for 6 can, not can. So
Yeah.
we're not supposed to destroy each other's robots, intentionally anyway. So
Do we need
okay.
to rewrite the rules to disallow combustion? Because I think the next one coming.
Say that again?
I'm worried.
Sorry.
I'm worried about your next option. Should we rewrite the rules to disallow combustion events?
I thought about it. They have these they're nail guns that actually use a gas cartridge.
Mhm.
And so every time you push a nail into wood or whatever you're, nailing, it's actually like a, basically a I don't know what it would be, like a 2-cycle engine. It actually
Mhm.
ignites the gas and shoves the piston down, and that's what, pushes the nails into the wood. And it would be a whole lot lighter than an air tank. I also thought about like paint guns. They use like 300 psi tanks on the backs of the guns, and I think they had, you could probably do something similar with that and have it be lighter than this, but I didn't, at the time the tanks were cheap. And
Have you considered a potato cannon?
yeah. Oh, you mean like throwing in a
Hairspray and ignition source, and
yeah, that gets a little tricky. Plus it involves flames, so I don't know, it's a lot more risky. Anyway, so the other approach was a mechano wheel setup where basically I would go down the course in one direction and not change it, and try not to change the orientation of the robot frame with respect to the course. It should be a lot easier to navigate. So I would have to back up in behind cans to get the can to go forward again. But that just seemed like it would be a much easier approach to figure out or to keep track of where you are. And I was going to have, these are two of the pulse output distance sensors there on the front. And I have two others that I was going to put on that. And, so I'd always be basically running parallel to the long walls of the course, and not have to do that much rotating or turning and trying to figure out, okay, now I have to use like some sort of either odometry or a compass heading, because compasses never seem to work that well on that where we have the competition. So that might be approach number 2, mechano wheels and perpendicular motion of the robot. So the third was actually going to be 3-phase brushless motors. I've had these 2 sets of 3-phase brushless motors with encoders on the back for a long time, and finally got around to playing with them, and they are much faster. It's like pretty much direct drive. The wheel goes right on the motor shaft, and the what is it? Simple FOC, field orientated control. There's a library that that you can use, that you can do angular positioning that's very accurate. It's has constant feedback, so it's kind of like I don't know which robot it was, but Karim had one where you could push it and it would pull back to its original position. So it would, like if you were in not velocity mode, but position mode, and you shoved it, or there was some disturbance where the robot got shoved, it would actually try to get back to where it was. So it's you can be very fast, and a lot faster than a geared DC motor. And so I thought maybe I could make up, have shorter transition times between grabbing a can and dropping it off, and then coming back and finding the next can. But it also means that positioning the robot has to be pretty fast to keep up with it. So don't know if that's going to work or not.
It's more the external factors that'll make a difference for you, not the speed of your BLDC versus direct drive motors, direct current motors. It's that's a level of precision and speed that's probably like a couple years away after you start experimenting with just getting your localization fully corrected with external sensors. It really helps to have completely separate odometry pods.
Okay. Yeah.
Which the ones that we use are generally either going to be the like dead wheel mecanums or omnis pointed in different directions.
Yeah.
And we use those to get rid of any of the slippage that's actually on the wheels.
Uh-huh.
And they'll give you a better sense of where you really are in a dynamic environment where you might be where your wheels might be pushed, or you might be spinning out because you're applying too much torque or whatever, right? It'll actually give you a better sense of where your robot actually is. And you can redo your repositioning based on your continuous localization. But that loop is generally slower than what you're talking about with going to the BLDC motors. So you would have to have a really, really high performance relocalization mechanism for that to matter. It's more just the BLDC gives you huge efficiency and torque capability.
Yep. Okay. So that might be option number 3 then, or further down then.
Yeah. Start working on it now and you'll have it ready in 2 years.
2 years.
Be able to take advantage of all of the performance you could possibly eke out of it.
Squeeze out of it. Yeah. So, got options.
Yeah. 2 years ago, I did mecanums and it would go X, Y. It wouldn't do diagonals. It just moved X direction and Y direction to go any place and not rotate or even move diagonally. So it worked pretty good.
Yeah.
I used ultrasound sensors to see where the walls are for localization, and it worked pretty good.
Yeah, I guess I could use the distance sensors because I could look in all 4 directions basically, front, back, left, right, and try to figure out, I'm actually where I think I am on the course for just looking at those distances. So, and those are pretty fast. I think they update at like a 30 hertz rate. And my loop is actually only 50 milliseconds. So anyway, too many options maybe.
So Ray, Ed had asked if you thought about option 6, a steam-powered robot.
Steam-powered? Not really.
Full steampunk.
That's a good option. Yeah.
Where it'll somehow press the button looking forward.
For one of those little sterno fuel steam engines to drive everything.
We will work on that for you.
Stirling engine, maybe.
Sterling.
External combustion. Yeah.
Hook the controller up electronically to my gas tank in the car. If you were to mechanically do it, that would be.
Okay, well, thanks, Ray.
Well,
Sure.
actually, I know that.
Yeah, it'll be interesting. Hopefully
I looked at it for my stupid controller thing.
I won't stress the mounts on the tank, and then instead of the blowing air forward, it'll blow the tank backwards or something. Yeah. That could happen. So. Maybe the first initial tests, I'll make sure I wear a face mask or something. Anyway, that was all I had. But anybody else have any new machines to do 6-can with, or?
Yeah, I'm just going to try to get my machine working better. Yeah. It was respectable last year, but it can be better.
I've been working on mine.
Pat, which LiDAR did you use? The RBNV LiDAR C1?
That's a C1.
Yeah.
So it runs at 10 hertz.
Yep.
And so got a Raspberry Pi module and a circuit board I created on the bottom. I've got a Raspberry Pi 4 at the top, solid state drive underneath the LiDAR, and then C1 LiDAR on top of that.
Mark, that the robot that you and Paul were playing around with, did that have a C1 on it as well? Or is that another one?
No, it's LD14.
LD14.
Yeah, it's more of a budget one than the C1. It still works great.
Oh. Well, this I think I found the C1 on for like $52, I think.
Oh wow, that's good.
$52.42.
Yeah, I think when I picked my C1 up, it was like 70 or 80, maybe.
Oh, okay.
Oh, that's good.
Yeah, I think it's they look like they're Cyber Monday, but it actually ends on the 4th. So I don't know which Monday they're talking about. But
Yeah, I was shocked that IMU. I pulled out of my drawer a B&O 55 and it didn't work. And then I remembered back in my head, oh, I broke one somehow. And online, it was like $44.
Mm.
Like, what?
Hmm.
But I found a relatively inexpensive one because I just need like 6 degrees of freedom just for this project. I don't need all the fancy stuff, or 6 degree of orientation. And it was like $10. So like a DS3. Yeah.
I think the MPU 6050, I believe I read somewhere it was being discontinued. It's a 6 degree.
6X. Yeah.
Yeah, that seems like that was used a lot on.
It's
What
all,
is
there's all sorts of libraries everywhere for it, in MicroPython, in Arduino C, everything.
Seems like even Harold was playing around with that one on his balancing robots, right?
I
Harold?
think he's asleep.
I think he is.
So, Karim, I'm not sure if you read, I muted you. It was getting noisy on your call. Does anyone have anything else to present tonight? Any questions for the group? Oh, is it going to be a short meeting, guys?
Yeah.
So who's working on RoboColumba or RoboRama? It's, of course, I got my robots, and I'm sure Scott's going to do it, and Pat and Ray, and
Yep.
Yeah, I'll be doing it too. Robot Sumo.
Yeah. At
Oh,
least
good.
Sumo.
yeah. Okay.
I do have a question actually about Robot Sumo. What is the ring made of?
Pardon?
We have a wooden.
Sheet of plywood,
It's plywood, and then we have a foam one that we use for playing around with. But yeah, the actual arena is wood.
Okay, gotcha.
Yeah. Looks like it's got some textured surface on it, doesn't it?
No, it's just good plywood.
Just
Just
matte
painted
black.
black.
Yeah.
Is it like a black MDF or like just a painted plywood?
It's a painted plywood. Yeah, sprayed with matte black.
Gotcha. And it has the white ring, of course, right?
Yep. I
Okay.
think it's like, I'll say, a 2 inch. No, about 1.5 inches. It's an inch or 1.5 inches like width of the white circle. It's
Maybe
not
then.
very wide.
Yeah.
I haven't checked it, but are the rules posted on the website?
Yep.
Okay.
I believe I think there's standard mini sumo rules to use.
Yeah.
Yeah, I think so.
All right, I'll take a look.
Let me see if I can find it real quick for you.
Yeah, I wonder if I don't know, a lot of the Zumos, I guess, are track based.
Mhm.
So
Yeah.
I wonder if you get a little bit more surface area on a track versus a wheel. So or
Probably.
if there's
I mean, technically you should, right? With
Mhm.
more surface area.
I've seen them used like for people. Different people have used the Zumos as a mini sumo base.
Yeah,
Yeah.
that's what mine is. Mine's a Sumo.
I have one as well that I was thinking of basically building into a mini sumo. So
Mm-hmm.
like I say, my other one has from the 90s, so it's a little.
Yeah, you should bring it as a yeah, for fun. put power on it and see the blue smoke come out. Yeah.
I was just going to ask one question. I haven't been doing robot stuff much for the last several weeks because too many other house-related stuff has gotten in the way. But I did order and have just received a few hours ago some of the nice STM 8x8 time of flight sensors, VL53L5s. So a slightly older variation on these things. Haven't done anything with them. I haven't even opened the packages yet.
Wow.
But they were $5 US each. So I thought that was a good deal.
That's a good price.
So I thought I'd play with them and see what happens. I understand these are the less sensitive versions, so might not work well out of doors. But should work well indoors. Is that correct? Mike, you've used these before. Right?
Yeah, I think I use the L5s on my Roborama. Yeah.
Okay. Yep. Well, I'm looking forward to hooking them up and testing them real soon now, I hope. Still some other household chores to do, but we'll see.
Great. $5. Where'd you get those?
AliExpress.
Wow.
So they're not Polulus or there's some Chinese manufacturer. Yeah.
Because you can't knock off the ST module, so you can't have a fake one.
I don't know. I mean,
they're too
They
complicated.
space of everything else.
They're way too complicated. Yeah.
The only manufacturer is the one who probably built the module because these are 6-pin module connectors on them. So some Chinese firm in somewhere, Shanghai. Excuse me. So we'll see. I will be looking around for some test software to test them with.
Do you know the depth of field on them?
It's stated as 4 meters, but I don't know how true that is. Right?
I think I got the 4 meters on Roborama. Yeah.
Okay.
Yeah, but it's like ideal conditions, lower light and a very reflective surface, and perpendicular to that surface and everything else.
I was thinking about
they don't like
light
round stuff.
sensors for the mouse.
Huh?
I was thinking about trying those time of flight sensors for the mouse, but the update rate was just too slow.
Right. It's fast.
Yeah, they're I2C. It's not terribly fast.
And you're looking to get 10 hertz. Yeah.
For my purposes, that should be a real great starting point. So we'll see.
Yeah, those micro mouse move a lot. At 10 hertz, you're through the wall already.
Yeah, 10 hertz, you're like 10 centimeters off sometimes.
Right.
Yeah, I was looking for an update rate of like, a kilohertz.
And Mini Sumo, they move really fast, and when they see the edge, they need to react real fast. So they need to be like 100 hertz or 50 hertz or
You might need.
Have you seen the Japanese ones? Those robots are insanely fast.
Yeah.
The micro mouse?
That too, but I'm talking about the Sumo robots.
Oh, the Sumo, yeah, they're fast.
Yeah, the Japanese mice are really, really fast. And they use the half-size ones. So there's not much weight that they're throwing around, so it's even faster.
Oh, that's a micro Sumo? Yeah.
Yeah, there is, yeah.
Yeah.
Yeah, they have half-size micro mouse. They have half-size Sumo. I think they have like micro and nano Sumo too. They got some small robots out there.
So is a half 5 by 5 centimeters then?
I believe so, yeah.
Wow.
I've seen some competitions. I don't remember where I saw it, but I think I saw one. It was about the size of a US quarter. But just a couple centimeters.
Yeah, that is small.
Wow.
I'd never fit my Weller soldering gun in there to work on it.
Yeah.
Wonder how big is the arena? Like 100 centimeters round.
Yeah, there you go.
Yeah, I'm trying to see if I can
Proportionally
find a
small.
picture of it. Oh wait, this is cool. Here, let me share my screen. This is really neat.
Yeah, 5 centimeters isn't even 2 inches. So
Mhm. Yep.
that is small.
I would love to find a source for the mechanics for that, because if so, then I could make an orange can for the 6 can that's evasive maneuvers capable.
There you go. Yeah.
Yeah.
Here we go. Look,
Just run away from
look how
Scott's
small these
robot.
things are.
You could use a swarm of those for a 6 can.
Yeah.
Yeah.
That'd be great. They can put themselves back on their spots.
Okay, micro sumo. That's what I have
There
to
it
find.
is. That's
That's
great.
amazing.
Yeah.
Wow.
I kind of want one. I'm totally not Googling them now.
It's amazing what people come up with.
It really
This
is.
is fun. Be hard to build, but it does look like a lot of fun.
Like J
That's
Sumo.
the fun part, building it.
Where does the battery go?
You need like 6 micro
They're
sumos
just
to carry
yeah.
that
Look, so
battery.
they're sitting on top.
Okay,
It's just like I'm glued or taped
Or
to the top of
out
the
front.
robot.
50 milliamp hour. Yeah.
Use it as a bumper. You know.
Yeah.
Yeah.
Wow.
Maybe 2027 a Roborama we can do a micro division.
I'm for it. That'd be amazing.
I have to do custom boards and circuits. I can't use off the shelf modules.
Yeah. That's amazing.
So you build a little micro sumo robot, and by the time you get the fab house to assemble it and get it ready, it costs you about $1,000.
Yeah.
But maybe the tariffs will be over by then, and it won't cost you $95 to have it shipped.
We can hope.
Yeah, it seems like the AliExpress, they all have little notes on the individual pages that, you know, if you look at a part and it's, you know, additional fees and taxes included, you know, so how much that is, that they're not really saying, but I'm assuming the additional fee is a tariff.
Mm-hmm.
Find out at checkout at the very end.
Yeah, I haven't actually done that to see if that if the price they quote you is, it says that it included it, so it shouldn't increase the price, but
Oh, okay.
I think I'm going to write down all the prices and then say, okay, check out, you know, and see what happens. You know, everything goes up by a few dollars, you know. So,
$100. Yeah.
let's hope not. Let's hope. That is too much.
The one you have to watch out for is the one I got hit with. I ordered something from Europe earlier in the year, and then I got a bill from UPS for $60 later.
Oh,
Hmm.
Oh, after the fact? Wow.
After the fact, like 3 months after I had received it.
Was it something big for? It seems like a
No,
pretty
it was a
high
book.
fee.
It was a
A
book.
book?
It was
Wow.
a book.
Yeah, I just had
I was
a
afraid that was
Kickstarter
going to
come.
happen on my first order. Hey, sorry, go ahead, Carl.
Well, I was saying I had a Kickstarter come from the UK that was like $87, but it had almost $30 worth of tariff on top of it.
Hmm. Yeah, that may be challenged. They may be going away.
Don't worry, it's not a tax though. It's not a tax at all on buyers. Not a tax. Only the manufacturers.
mm-hmm. Mm-hmm.
How about we leave the political aspect of things out?
Yeah.
Yeah.
I was going to try to use this for my battery pack, but that basically is my 10 by 10 centimeters.
Yeah.
Like four double A's.
That's what the Zumo has, Mike. It has the 4 AA battery box.
Yeah, but I just couldn't fit it on unless I put it real high, and then it's the center of gravity is all wrong. And
Yeah.
They fit underneath.
Oh, the battery box is on the bottom. Huh?
Yeah.
Yeah, I was surprised they didn't. They upgraded the processor in those. They should have gone to lithium.
I think they use it for the weight. They might use it for the weight of it because they're really light without the batteries.
You can do Doug's idea as well with the AA batteries is use the lithium rechargeable that have the 1.5 volt regulator on them.
Mm-hmm.
So it's a little 3.7 volt cell, and it has a regulator built into the AA battery.
Yeah, I was looking at those.
He says they're good. I've thought about buying them for that little Zumo, but
yeah, I kind of wonder how it's like, test equipment, your multimeters and stuff use a 9-volt battery. If you did get one that was lithium ion based, I wonder if adds a lot of noise because it's a switching regulator that,
Yeah.
Good
a lot
point.
of noise for your.
I was concerned that it would starve my motors when I'm trying to move quickly because they want like an amp or so to get fast movement.
Yeah, I don't know what. Are most people using NiCads as the AAAs, or are they using something else? Just a regular
I'm using
carbon zinc, or
I'm using lithium packs. Yeah.
what I meant in the Zumos.
The AA's. Yeah, this is Amazon Basics.
Yeah.
Yeah.
Okay.
Yeah, they got a lot of they can
Pipeline.
put out amps. Yeah.
Oh, can they? I don't know. Yeah, I don't know what the characteristics are.
how are the Amazon Basic batteries?
They work.
I've been buying the Duracells at Costco.
Ooh.
But
Yeah.
Duracells used to be,
And
they never leaked. And now I find that they're leaking all the time.
Oh no.
Oh yeah.
Yeah. I mean, I don't leave my batteries in. Like, I have I found this really. Actually, I think it was from another kit, but yeah, it fits the Zumo and the batteries, and I had this little bit of sponge that I could sit the Zumo on when I'm working on it. But yeah, I always take them out. Like, whenever I'm done with it, I put them out. Just out of habit now. Because all batteries leak eventually. So
Yeah, well, that's it. And they seem to leak only when you leave them in a device. Otherwise, if they're out of the device, they never seem to leak.
yeah.
I've gone through my battery bag before and seen some leaking just in storage. They're probably like 10 years old or 5. Something like that.
Yeah. My wife and I work at a food bank, and one of the arrangements we have is with the SPCA of Dallas, and this person that works there gives us all kinds of dog food, and she also has these Amazon return boxes that she can't really do anything with. So my wife's been taking them, and we give them away, this time of year, to clients that come to the pantry. And one of the things that was in it was an Amazon Basics. They were 8 9-volt batteries, but the package had gotten crushed. So some of the batteries are, like buckled in a little bit on the sides. It's like kind of a rounded rectangle. And I checked them all out. They all, the voltage is okay, but I don't know. The connections are sometimes cockeyed, for the 9-volt connector. I don't know if they're going to work or not, but yeah. So we get things like that, but it's like she's doing like generic categories, like women or men, over 21, and then I think 3 different age groups for kids. Anyway, so we're, I was looking for the thing of, you pick a gift for somebody, I know there were hair straighteners and blow dryers and that kind of stuff. And sure enough, she's going to go outside and, give a bald guy a hair straightener or, a blow dryer. Oh, well. So, or, socks for double amputee or something, it's like, what am I going to do with these? But,
Yeah.
It's the thought that counts, Ray.
Yeah. So. Anyway.
Well, guys, is that it?
Yeah.
I think so.
Okay. I guess.
Thanks, Matt.
I guess we'll call it a night.
All right. Thank you.
Sounds good.
Night, everyone.
Good
We'll
night.
see you.
Bye.
Hello.